Alright, gonna do a video here about applications of conic sections. This will be supplementary to some of the other videos we have about conic sections, which are not made just yet, but I hope to make them soon. So let's start. I think I have a parabola. What? I got a parabola one first. Yeah, parabolic arch is 27 feet high. It spans a parkway. Parkway is a road. If you don't know what a parkway is, it's a road. Let's draw a picture of what this is talking about. So it's like there's the road. Then like in the center of this road, there's this divider thing, and it's 50 feet wide. We want to know in this problem, what we want to know is like the length of the parkway, or how wide the parkway is, how wide the arch is, which is how wide the parkway is. There's an arch, does this, okay? And it says a few things. It says that at these like parts right here, that this height is 15 feet. So we know that there's a 15-foot clearance right there. And it wants to know on the total height all the way at the top here is 27 feet. Okay, so we want to know how wide the arch is. Alright, let's see. So one thing we need to do for almost all these problems is put an origin somewhere. And to me, I think the origin, the best place to put it is going to be directly underneath what will be the vertex of the parabola. So if we decided that that's 0, 0, that means that this HK up here at the vertex is going to be 0 in the x direction and 27 in the y. Okay, we also know that this point right here, I'm going to draw an arrow to it, that point right there is 25 over because it's halfway. This is 50, this center section is 50 feet, so halfway is 25, which means that this is 25, and then again the clearance is 15, so that's 15. And what we want to know eventually is like, what's the x coordinate over here? We know that the y coordinate would be 0. Alright, so let's see what happens when we start messing with some stuff. Well, this is an upside down parabola, so in vertex form, the equation for upside down parabola would be this. I mean, just a parabola that opens downwards. Okay, now if we look at this and we call, we're going to call this x and y, and this is h and k over here. We have a y, an x, and an h, and a k. So we have all these things, so we're just going to plug them in. Color blue. So y is 15. Negative a is what I'm trying to find. X is 25. H is 0, so minus 0 squared, plus k, which was 27. So let's clean this up a little bit. 15 is equal to 25 squared is 625, so it's negative 625a plus 27. If we subtract 27 from both sides, we will get that 12 is equal to negative 12 is equal to negative 625a. And that a would be 12 625ths, which I don't believe that reduces, even though they're both really nice juicy numbers. So a is 12 625ths. So if I want to write the equation of this parabola, which is not needed for the problem, but it would be y is equal to negative 12 625ths x squared plus 27. Alright, that's the equation of that parabola according to where we put the vertex, according to where we put the 0, 0, the origin. Now, what we want to find, remember what we want to find for this problem is this value here. So we know what is the value of x when y is 0. Well, for that, we're just going to plug in 0 here. We're going to plug 0 in for y, and that's going to equal negative 12 625ths x, which is what we're trying to find, plus 27. Okay, so now let's just figure this out. Move this up here. So let's subtract 27 from both sides. And that's going to give me negative 27 is equal to negative 12 over 625 x squared. If you solve this for x squared, you'll get that x squared is equal to negative 27 times negative 625 divided by 12. I don't know what that is. X squared is equal to x squared is equal to 16,875 divided by 12. We just need to square root of this. Whatever square root of this is 37.5. So 37.5, with 37.5, the value x we just found is this value right here. And the question asks for how wide is the arch. So we want to know the entire width, which means this here is also 37.5. So the entire width is 75, right? 37.5 times 2, 37. It's 75 feet. So there you go. Done. Next. Here's another parabola problem. It says the roof of a gym is shaped like a parabola if the gym is 160 feet wide and 80 feet tall. Write an equation that models the shape of the gym's roof. There are many possibilities. Okay, it says put the origin underneath the vertex, so underneath the high point of the roof. So let's draw another picture here. This one's going to look just like the last one. Okay. Okay, it's a parabolic roof, and it wants us to put 0, 0 right here. Okay, and then the vertex HK is going to be the top of the roof. And if this is 0, 0 here, that means that this point, the vertex, it went 0 over in the x, and it's 80 feet tall, so it must be 80. Let's see, what do we need? Oh, we just need the equation. Okay, well, the equation of a parabola models any point xy that's on that parabola. So look, here's a point on the parabola, and the coordinates of this point, because the gym is 160 feet wide, that means half the length of that would be 80 feet. So the coordinates of this point then must be 80, 0. And that's going to be our xy. So just like the previous problem, we know that the equation of a parabola that opens downwards is this. That's in vertex form. And for this then we have an x and a y, and we have an h and a k, and the only thing we don't have is an a. And we can find that, and then all we need to do for this is write the equation. So let's plug some stuff in. Because y is 0 is equal to negative a, don't know. X is 80 minus h, which is 0, squared plus k, which is 80. So that's 0 is equal to negative a times, that's 6,400, plus 80. Subtract 80 from both sides. And we get negative 80 is equal to negative 6,400a. So let's clean this up. A is going to be 1/80th, right? I think, isn't it? 80 divided by 8. I did this right? I'm not going insane. Yeah. Okay. I literally just did 80 times 80 in a calculator. Okay. So that's A. Now, if we want to write the equation of this, we used x and y. We used the h and k that we had, and this a, which gives, then we write y is equal to, and it's negative because it's upside down. It's downward facing, downwards opening. That's a, and then x is x is x minus h, which is 0, so that's that, plus k, which is 80. Done. That right there is the equation of of this gym's, the equation that models this gym's roof. Find equations for a set of points in a plane such that the sum of the distances between each point and a set of points. Ooh, okay. Let me just draw quickly what this says first, and then we'll have a discussion about what this is talking about. So, 2 zeros right there, and negative 2 zeros right there. What this is saying is that there's a set of all points in a plane. This sounds like a curve or some kind of line. Like, for example, if we had this point right here and like this point right here or something, it means, say both of those points were on this curve. What it says is that this distance plus this distance is some constant, and that constant is equal to a. So like d1, d2, like d1 plus d2 is equal to, in this case, 8. Now, if you remember about these conic sections that we've been talking about, one of them has a definition that sounds a lot like this. It is the set of all the points in a plane that the sum of the distances from two set points, the foci, is a constant. And that conic section was an ellipse. And in fact, we found out, because what we did was we assumed, what if we had a point right here? Well, we defined this length here as a, and we said, okay, if this equation is true, that this d1, d2, the sum of d1 plus d2 is some constant, that means that this distance right here, so this distance here was c, and this distance here was c. So we went all the way from there to there, and then back to here. So what we did was we went a distance of a right there, and then we went a distance of c here plus some little extra piece, and c plus that extra piece is also a. So we know that this should be equal to 2a, which means for this problem 2a is equal to 8. So a is 4a, the length of half the major axis. The longer axis is 4. We also know that since these 2 points are foci, that c must be 2, because it's 2 in either direction from the center. So this is all located at the center. The center, hk, for this problem is at 0, 0. So we know a bunch of stuff. We know the center, we know a, and we know c. That means we can find b, because for an ellipse, c squared is equal to the absolute value of a squared minus b squared. We want to know b squared. So if we solve this for b squared, we'd get that b squared is equal to, what do we get? A squared minus c squared. And b squared would then be equal to 8. So a squared would be 16, and c squared would be 4. So b squared is 16 minus 4. B squared is equal to 12. And we don't actually need b, because we're going to write this. We want the equation. And you'll need to recall that the equation of a parabola centered at the origin, that's not an equal sign, I don't know what I'm doing, is x squared over a squared plus y squared over b squared equals 1. So we plug in stuff we know. X squared is x squared. A squared we just said was 16, plus y squared divided by b squared we just found was 12, and that's going to equal 1. And that is the equation that will fit this little explanation, this little description we got. Satellites can be put into, okay, so there's orbits. Satellites about orbits only need, okay, so let's draw a picture to represent what's happening here. Now notice a few things. This is 4420, 4416, and then the radius of the Earth is 3960. So if we were to draw the ellipse that this is talking about, you can see those numbers are very, very close to each other. So if we were to draw an ellipse here, and let's assume that this ellipse were centered at 0, 0, the ellipse would be very circular. This is a terrible picture. I have to delete that, I'm sorry. I'm not going to be able to do a good job at this on this computer. Oh god, it's terrible. Anyway, that's going to just have to suffice for now. That's that, but there's an Earth here, and the Earth is at a focus. The focus of these ellipses is going to be really close to each other because these numbers are so close to each other. And we know that the Earth's radius is 3960. So the Earth is right here, and what we're looking for in this problem is this distance right here, which would be the closest the satellite would get to the Earth. I know it looks like right there would be closest, but that's because my drawing is terrible. And I cannot make it better, I'm sorry. And then this distance right here, which would be as far as it's getting. So let's do a few things. We want to figure out, essentially, if we can figure out, so let's just draw some light marks here. From here to here, that's basically A, right? That's the major axis. This length is 4420. Okay. We also know that this is the center of the Earth right here, and this is the edge of the Earth, if we're cross-sectioned. And that distance right there is 3960. It's the radius of the Earth. And then we know that this distance right here, between there and there, so that distance right there is C. So if we want to find this value right here, we would say that it is 4420, and then essentially we need 4420, because this is 4420, so 4420, and then we're going to subtract whatever this distance right here is, which is 3960 plus C. I think that makes sense. Yeah, it does. Okay, so that's that distance. Then conversely, this distance right here, because we'd be looking at, conversely isn't the right word, on the other hand, this distance right here to this distance right here would be the radius of the Earth, but less C. So this distance, the other part of this question, is asking for 4420 minus 3960, but then minus C. So that's the difference here. We need both of these answers, which obviously both of them we need C. There's an equation for an ellipse. C squared is equal to the absolute value of A squared minus B squared. So these are big numbers. I think I wrote one of them down. C squared is equal to absolute value of, this would be 4420 squared minus 4416 squared. C squared is going to be equal to, after you do that math, 35,344 or something like that. When you take the square root of both sides here, you will get that C is equal to 188. I know it's plus or minus 188, but we just care about what C is right now, so just deal with the plus. Okay, so that's C. So now all we need to do is plug C into those two equations, and we'll say the closest, which is this one, is going to be 4420 minus 3960 plus 188, and that equals 272. Okay, farthest or furthest, that's the lowest. Okay, and then the highest would be 4420 minus 3960 minus 188, which would be 648 miles. And I feel like those are the right answers. Okay, cool. Next, two radar sites. This is a hyperbola for sure. I have a better slide. Well, it says it's a hyperbola. We need to find the equation of hyperbola. So let's draw what this is talking about. It says, oh, one of the radar sites is at 0, 0. This is a focus. One of the radar sites here, this one and this one, these are the foci. So let's draw this. We have a coordinate plane, and we have a focus right here and a focus right here. Now we know that the distance between these foci is well, there's a center somewhere too. Let's just put that for now. The distance between these foci is 160 feet. Okay, which means that the distance from the center to a focus is 80 feet, which means that C is 80. Okay, that's what the definition is for this hyperbola. We know then also that we can kind of sketch in what this hyperbola would look like. Like the vertex is going to be somewhere between the focus and the center. I don't know where. Let's just assume it's going to be like, so it's going to be right there, so it's going to do something like this. There'd be another vertex over here. Something like this. Okay, and what this problem is saying is that if there's a plane somewhere, like let's say it's right here, it's saying that at this plane, well, let me draw a better picture of a plane. I'm capable of that, maybe. It's got like fighter stuff on it. Okay, so this plane is right now at this point, it's 100 miles away from that tower, but the one that was at 0, 0, it's 200 miles away from that tower. Now, the geometric definition of a hyperbola is that this distance, whoa, why did that happen? That this distance right here and this distance right here, the difference between those distances is some constant. So 200 minus 100, which is 100, this is a constant. The difference between, like even if this plane was over here, like that distance and that distance, the difference between them would be that 100. And we also know, because if we were to select this point right here and apply the same definition, that the distance between, like if you take this and you take this, all that is this distance, right? We took that distance right there minus this distance right here, which is equal to this distance right here, which is 2a. So we know that 2a is equal to 100, therefore a is 50. We know that c was 80 from before. Okay, which means now we can find b. Because for a hyperbola, c squared is equal to a squared plus b squared. So c squared is equal to 2500 is 50 squared plus 6400, which is, wait, we have c squared. What am I doing? We want b squared. So let's solve this equation for b squared. B squared is equal to c squared minus a squared, right? Okay, so b squared is equal to c squared, which is 80 squared minus 50 squared. B squared is equal to 6400 minus 2500. B squared is equal to 3900. And I don't care what b is, because all I want is the equation. Remember that the equation of a hyperbola is x minus 8. This is a sideways hyperbola because the x squared is going to be the positive term. Minus y minus k, quantity squared divided by b squared is equal to 1. So fill in what we know. So x is x. H, so h is defined as the center of the hyperbola. That's something we should probably specify. We know that the y coordinate of this, the k, like this is hk, the y is definitely 0, and the x is, we started here, we went over here, that's just c, that distance, so h is going to be 80 also, so x minus 80 quantity squared divided by a squared, which we said before was 2500. Yeah, this 50 squared, 2500 minus y minus kk0, so y squared divided by b squared, which was 64. Oh no, it's not. B squared is 3900. We just said 3900 equals 1. That is the equation of this weird hyperbola that defines all the possible locations of this airplane. So I guess like shoot at all those locations at the same time, I guess? I don't know. No, it's actually take a second measurement later to confirm where it would be, and then shoot that place. It's pretty cool. That's how radar works. Okay, last question I think here. A comet's path as it approaches the sun can be modeled by one branch of the hyperbola. So remember what it means by branch. Branch just means like, first of all, this is the positive term. Y is the positive term, so this is going to be an up-down parabola. But it means by one branch means just like this one. Like there's two branches. We're just going to look at one of them. Where the sun is at the focus of that part of the hyperbola. So the sun is either here, here, or here. And you should find the coordinates of the sun, assuming it is at the focus with the non-negative coordinates. Okay, so if we put 0, 0 right there, then this is the one we're going to look at for this problem. That's the branch, because it will have non-negative coordinates. All right, round to the nearest hundredth, and how close does the comet get to the sun? Okay, so let's just draw a picture. I'm gonna put the origin down here because I know I'm only gonna have. I'm only look at the positive branch of this hyperbola. So it says, and this is gonna be b squared right here, and this is gonna be a squared right here. So we can draw a few things in. B squared, if b squared is 1096, that means that b is the square root of that, which I don't know what that is. Square root 1096. It's whatever it is. It's like 33 point something, so it's the square root of 1096 exactly. Okay, so we can go, if we went up 1096, we'd be at the vertex, right? Because of this is now the transverse axis. All right, if you could read that. You probably can't. I should just erase it so as not to embarrass myself. But that's where the vertex is going to be. And the 4133, a squared is 41,334. So a is going to be approximately 41,344. Second square root of that. 203-ish. 200-ish. Okay. So that's over here. Now, you can imagine that's half of like a hyperbola box. And if I were to draw in what the asymptotes would be, would do something like this. Which means this comet is doing something like this. Like insane. Like it's a, oof. My arm hit the desk and it got screwed up. Okay, so it's a really like wide parabola. And the sun is like right here at some focus. Okay, so we don't know what this is. This distance right here is c. Okay, and the comet is like has a tail on it. Okay, so we're gonna need to find c, because c is gonna tell us if we find the actual location of this focus, the sun. I'll call it the sun. That's part A. We want to get the coordinates of that, so we need c. So for hyperbola, c squared is equal to a squared plus b squared. So c squared is equal to 41,334 plus 1096. C squared is equal to, I have no idea. It's 42,430. C then would be approximately, when you take a square root of both sides, 205.99. Okay, so the coordinates then of the sun would be 0, 205.99. Okay, and these are all in millions of miles, so it's like a mega mile. So anyway, that's the coordinates of the sun. That's part A. This is the answer to A. B says how close does the comet come to the sun. So B is looking for this distance right here, because at this point right here, the comet is going to be closest to the sun, which we know that that distance right there is B, and this distance right here is C. So if we get C, so for part B, this is confusing because now I have a bunch of different letters. I want to know what is B minus C. Okay, where this is, again, that's B and that's C. Okay, well, I mean, I already have these values, right? So C, okay, so I want, it's not C minus B, it's C minus, it's C minus B, not B minus C, right? Obviously C is bigger than B. Okay, so C, which was like square root of 42,430, because we're going to use exact numbers, minus B, which was the square root of 1096. This is going to be, whatever this is the answer. I don't know what this is, so second square root of 42,430 minus the square root of 1096 is 172.88 million. What happened there? Million miles. That's how close it got. Oop. Why? Million miles. There you go. That's it. Those are a bunch of application problems for hyperbolas. This shows you why they're relevant in real life. And again, supplement this video with some of the basic stuff about parabolas, ellipses, and hyperbolas. Okay, thank you for watching.